Hello guys, how are you doing? Can you guys hear me well? Someone in the chat said, I can't hear you well. What about now? Is my voice clear? Is too low. Okay, just a second. What about now? Is it better? All right, cool. Welcome guys. We just Salman walk you through Coursera on how to get your free professional certificate. Was it clear enough for you guys? Do you need any further help with it? Did anyone register and got his free course? All right, so follow the steps as Salman said. And if you have still any difficulties with getting your professional certificate, just send a message in the group or send me a private message. Sorry, I haven't been able to respond to, it says free course. It isn't free professional certificate, right? It is inside the certificate, yani, let me show you. So now we are on Coursera, right? So you have free courses like these, all right? You have free courses like the big data one. This is a course, normal course, right? From University of California, San Diego. There is just courses here, and you can find guided projects. You have unlimited guide projects to walk through, all right? So you can do as much as you can. And you will find some specialization. Specialization courses means it is a course that consists of other courses as well within it. So this specialization course for Python has 5 different courses inside of it. So you will get all of them free. And if you finish it, you will get a general certificate for this certificate for this specialization from University of Michigan. All right. So you have courses, you have guided projects, and you have specialization, and you have professional certificates. In the professional certificates, you will every professional certificates has inside of it different courses, and all of these courses, if you enroll in one of them, if you enroll in, for example, the data analytics, which I did, so it says enrolled, and inside of it there is how many courses? There is 8 courses inside of it. So all of these 8 courses are free for you to learn. So after you learn them, finish their quizzes, and after you pass, the grading pass is about 80% or something like that. So after you get this grade, automatically you will have a certificate, professional certificate from Google and Coursera in Google Data Analytics, or Google UX Design, or IT support, or project management. And there is another professional certificate from Facebook if you are interested in social media marketing. There is some courses from Salesforce related to IT with business. So if you are into that, you can take one of these courses. They are really good as well. So this is basically what you have. As it says above, you have access to unlimited guided projects and one free course per year. For me, I chose the data analytics certificate, which has which should be completed in about 6 months. If I study only 3 to 4 hours a week. So they are pretty lengthy, and there is a lot of good resources here. So I highly suggest to take one of the Google certificate courses, maybe the Facebook one if you are into social media marketing, or the Salesforce ones if you want to go to the business route with IT. All right. So it will help you a lot if you want to maybe work in an investment company or a consultant company or something like that. So is it clear for now? Okay, for you, Sammy. Sammy says it says for you trial, right? Make sure that you are on Coursera for students and you already registered with the university account, not your personal account. So please write your email, university email, register with it. And after you register with it, go to Coursera for students. And you will all, any other than Coursera. What do you mean, Kumar? I didn't understand your question. These courses here are the only ones that is open for students right now. They change every week or every 2 weeks. So be on the lookout if you want to register in one of the courses. Please make sure that you register with your university ID. It will ask you when will you graduate, your major, stuff like that. Make sure that you are on Coursera for students. If you are on Coursera, all courses, you might find what Sammy found, which is enroll for free or something like that as a trial. All right. So if I open this, for example, it will say for me enroll for free. All right. So this will ask you after 7 days or something like that, or 14 days, to pay monthly fee. We don't want that. Go back to Coursera for students and pick one of these. All right. I hope it's clear. If you still have any doubts or any problems with it, just send me a screenshot. Tell me what you did and what you want to do, and I would be happy to help. Just take in mind that I'm sometimes busy. I'm sorry, guys. It's out of my hand. I will try to respond as much as possible to everyone. So, but it might take a little bit of time. All right. So I hope you excuse me for that. All right, so we already took a lot of time explaining this, so I might end up explaining a little bit about the course and finish the rest next time. And I want to take your suggestions, guys, at the end of the session. So please stick with me because I really want your feedback. Okay, so welcome, guys. Our session is for today is from the weekly series Best Practices, which is a weekly series that we discuss how to be a better engineer in general. whether a software engineer, solution architect, network engineer, whatever have you. If you are an IT major, these best practices will work on your favor. All right. So I was kind of these sessions will be sometimes heavy on theory a little bit. I will try to include real world examples as much as possible, but just take in mind that some principles need to be established as theory first. All right. And I will include the applications for it later in the upcoming courses. Once we establish the foundation, we will try to practice with it and implement with it. All right. So I usually pick topics for these sessions from books. All right, well-established books that have its weight in the market, in the IT market, written by professionals. So I read these books and summarize it for you. All right. If you want to help in summarizing these chapters of the book, you are more than welcome to join me, and we can work together on it. No problem. All right. So the source material for this week, I took one of the really good selection of books that I have, which is Good Code, Bad Code. Think Like a Software Engineer by Tom Long. Tom Long is a well-established software engineer, works at Google. He wrote this book by the company Manning. You can find the book on manning.com if you would like to purchase the book. It's a really nice book, and I will walk you through what is inside that book. All right. So inside that book, there is 4 different units. All right. Every unit has different chapters inside of it. All right. So the first unit is in theory. So this unit have 4 chapters, which focuses on the most fundamental theory parts, which is code quality, layers of abstraction, thinking about other engineers, and errors. All right, all of these are different chapters. The next unit is in practice. So you apply all of that you studied in the theory part in actual practice with actual code. All right. So in practice chapter you have in the practice unit you have the chapter Make Code Readable, Avoid Surprises, Make Code Hard to Misuse, Make Code Modular, Make Code Reusable and Generalizable. All right. All of these have sample codes in them. We can play with them and really try to transform our code into a well written and documented code. Right. The next unit, which is unit testing. After you learn the theory and you apply the practice, you have to unit test your code. All right. So we will know the unit test principles and the practices that we can apply to achieve these principles. All right. At the end, there is an appendix. This appendix have some resources that we are going to use throughout the book. All right. The book is pretty lengthy. It has a lot of really useful topics. So I highly recommend it. If you have time, you can read it on your own. If you don't, we have sessions weekly and we will go through this book. All right. I'm open to your guys' suggestions. If you have really good suggestions, good book suggestions or recommendations, please send it to me in private or in the chat so everyone can benefit from it. So we can take from them some topics as well. All right. You guys can see the screen, right? Oh, the screen is not shared. I have been really going through the slides without sharing. Sorry, guys. So again, this if you guys can see the screen, please tell me. You're welcome, Kumar. Sami, can you see the slides? Kumar. Okay, I think it's shared right now. So this is the book. If you want to, if you want to look for it, I have the link for it here. I'll send it in the chat. If you want to buy the book. Manning, the company Manning has different books as well on very specific and general topics related to IT. So I highly recommend if you find a book that you are interested in, you might buy it or look at the preview before you buy it. All right. This slide is what I described. We have the in theory unit. It has good quality, layer of abstraction, thinking about other engineers' errors. And after we go through the theory, we will go to the practice. Want to make our code readable, avoid surprises, make our code hard to misuse, modular, reusable, and generalizable. Right? After we implement our code, we need to unit test it to make sure that everything works as intended. So we will discuss some principles and we will put them into practice. In the appendix, there are some additional resources that might help us throughout our reading in the book. All right, cool. So today I will discuss this chapter, which is code quality. Unfortunately, I'm not gonna finish the whole chapter today. I was planning to finish it today, but since we started a little bit late, I will give you a really good introduction to this chapter. All right. If you guys want to stay for longer, I can go through the program. No problem. All right, so the code quality. The code quality, we will discuss in this chapter how code becomes software, the goals of code quality, the pillars of code quality. Does writing high quality code slow us down? And just a quick down summary of all the things that we discussed in this chapter. All right, can you guys hear me well? Can you see the screen? Please say yes in the chat. Okay, thank you, Kumar. Thank you, Layla. Thank you, Sami. Thank you, Sadiq. All right. So let's have a little bit of an introduction. Why it's important to write quality code? What do you guys think? Why should we write quality code? Why can't we just write or take copy-paste code from someone and just paste it? And if it works, it's fine. Do you have any suggestions? Yes. يعني, why it's important to write the quality code, not how to write it, why it's important in the first place. Will be easier for others to understand, I guess. That's really good. Yeah, we will discuss that as well. It's really important to to make your code very readable and easy to understand and well documented. Because we work with teams and we need to reference it later. Yeah, of course. Many times it happens if you work on a project and you leave it halfway and you come back to it again after maybe a week or two. You say, what what did I do? I don't understand any of this. How did I think of that again? So that's is a sign of a problem that you have to encounter. Leila said you have to work on team and reference it later, cleaner code, better performance. Yeah, of course. Right. Really good answers. I'll just say, yani, as an introduction, you probably use a lot, maybe hundreds or even thousands of different pieces of software in the past year or even the past half year. From Gmail, maybe slides, maybe Excel sheets, maybe Windows, whatever. It's a piece of software. Every program installed on your computer, every app on your phone, all of these that you are connected with. We interface with software a lot. All of us do. So to have a well-behaved backend system that is there is a lot of pieces in the software that we depend on without even necessarily realizing it. For example, we trust our bank, right? We trust our bank to have a well-behaved backend system that isn't going to unexpectedly transfer the contents of our bank account to someone else, right? Or maybe share our private information with someone else. We trust our bank to do these basic jobs, right? Or suddenly put you in debt with dollars, right? So sometimes we use really good and user friendly and well planned and thought out softwares, and they are delight to use. They do exactly what you want, how you want it, with a very few bugs, if any, and it's easy to use. But sometimes on the other side, we use softwares that might be horrible to use. They have a lot of bugs. They crash all the time, and they are unintuitive. They are not easy to use. So some piece of software are obviously less critical than others. So if I'm using social media, for example, and you have a crash, for example, it is not that critical of a crash, like, for example, an airplane system. In a plane that is flying 3,000 feet in the air. If there is a bug or crash in the airplane system, it would be very critical. It would be very dangerous, right? So it depends on the app. It might be annoying. It might be dangerous. It depends on how critical this software is, right? So, for example, a bank system with a crash or a bug may potentially ruin lives. Actually, ruin lives. Put some people in debt. Make them depressed. Maybe a medical system which provided the wrong prescription, for example, for a patient. So we have to very be critical about our system. And even if it's not that critical, maybe I developed a social media app. So what if it crashed or something like that? If something like that usually happens, you lose part of your competition. يعني people will eventually go to your competition for a better experience. So you will eventually ruin your business. All right. So, of course, writing quality code will help you to face all of these problems. All right. So, how quality code can affect the quality of software? Let's have this quick comparison between high quality code and low quality code and its effect on the quality of the software itself. If the original software requirements, let me turn on the laser. If the original software requirements are fully met, then you have a high quality code. If they are not fully met due to unhandled edge cases, for example, if someone asks, if an app asks someone about their age, and someone said -16, and you didn't manage this edge case or this alternative scenario or something like that, how your app will behave? Will it crash? Will it just accept a wrong, unexpected value? So you have to take that into consideration. A change in requirement, maybe after you implemented something, the business required you for a change in the features of the software or different requirements. So if you have a high quality code in the first place, you will only encounter minor additional work. But if you have a low quality code, a major re-engineering and refactoring required, because your code is not that of a high quality. It doesn't maybe have a great documentation. It may be it is not an optimal solution to solve the problem. So it might be even yani, you want to engineer the whole thing again from the ground up because of misuse of the code, right? An error occurs. What happens if an error occurs? If your code is a high quality code, your system will recover or fails with some smoothness, you can say. If, for example, if you have an account on Instagram and you are browsing different profiles or whatever, and suddenly the app crashes. After you open it again, you will see your data is still there, your status is still preserved, nothing is lost, maybe something like that. But if your code is not that high quality, you might enter undefined state or data potentially corrupted. So you might open your app again, you find all your data lost, there is no save, automatic saves or caches or anything. So you have to really handle these things. An unforeseen scenario, it's the same thing. If there is unforeseen scenario, you probably put it inside the use cases and you probably have dealt with it. If you have a low quality code, you didn't deal with it or you didn't think about it. System under attack, system stay in a safe state, not compromised because you have a high quality code, you implemented security in a good way, in a good architecture. If your system is under attack and you didn't deliver a high quality of a code, you might your application might be compromised, right? So high quality code is very, very essential, right? This is just quick comparison between the two. All right, how code becomes a software? All right, before we dive into talking about code quality, it's worth to briefly discuss how code becomes a software, how these snippets of code compile up to become a software. Software is made of code. That is obvious, of course, and doesn't need any stating because it's obvious. Um, what can be less obvious though is the process by which code becomes a software running in the wild. So running in actual real world application, real users are using it. So here, code generally doesn't become software running in the wild or on the internet or on the public to use. Um, there are usually various processes and check-ins that let you ensure that the code does what it meant to do, that doesn't break anything else, right? So these are often referred to as software development and deployment processes. You don't need detailed knowledge of these processes for this book or for these sessions. It will help you just have a high level of how software development and deployment processes usually work, though it is not that necessary for our type of session. What is a little bit necessary though is to establish some terminologies that we are going to use throughout the book. All right, so the terminologies are code base, submitting code, code review, pre-submit checks, a release, production, right? So code base is the repository of code from which pieces of software can be built. And if you have a repository, you get the code from it, so you can build software. It's typically usually managed by version control system like Git, GitLab, GitHub, stuff like that, right? Submitting code is sometimes called committing code as well, or merging a pull request if you are familiar with GitHub. A programmer will typically make changes to the code in a local copy of the code base on his local machine. Once they are happy with the change, they want to submit it to the main code base, which is, for example, on GitHub. So that's the process of submitting code, right? Code review. Code review. So many organizations require code to be reviewed by other engineers before it's submitted into the original code base. This is like having your code proofread, right? A second peer, a second colleague maybe can maybe often spot some issues that you didn't notice. All right. So before submitting the code, there is usually a code review. All right. Pre-submitted checks, sometimes called pre-merge hooks or pre-merge checks. These will block a change from being submitted to the code base if the tests fail, right? Or the code does not compile. So in the real world, when someone commit their code or submit their code to the original code base, there is usually an automated tests that runs in the background to check if the new code, the new base of code that you wrote is well integrated within the original code base or not. Will it cause issues or not? Will it compile or not? So if it fails, it won't submit it to the code base. If it succeeded, the test cases, it will be merged with the code base. A release is a piece of software. It's built from a snapshot of the code base. After various quality assurance checks, this is released to the public. And after the quality assurance check it, how to learn coding language. I will answer that, Kumar, in a little bit. Okay, sure. Maybe at the end of the session, we will have open discussion, and you are welcome to ask whatever you want. I'm free, right? So, what major are you in, Kumar? Okay, so release. It's a version of the software. You might seen it version 1.3, 1.3, 1.3, or something like that. It's a version that got checked by the quality assurance and then released. All right. When a new release comes, it will go through the quality assurance. If it goes to, successfully through the quality assurance, it will be released to the public. Production is the proper term of the word that I used a lot, which is in the wild or in public. You have a production software now that people can actually use, right? So your code will be running in production after a release, right? Does these sound good? Do you have any questions about them? The session should end. Yeah, I'm recording the session, yes. Well, the session will end in about 15 to 20 minutes. We won't take that long, maybe less, right? So let us discuss the processes of how code becomes software running in the wild or in production, right? There is key steps that are usually taken. Sometimes it's different from a company to another, but usually an engineer will work on a local copy of the code base to make changes. So he will take a copy of the code, he will edit this copy of the code. And once they are happy with what they achieved or what they implemented, they will send these changes for a code review. So another engineer will review this code and maybe suggest alternatives or edits in the code or something like that. So once both the author and the reviewer are happy, the code will be submitted to the code base, right? Releases will be periodically cut from the code base, right? The frequency of this can vary a lot between different organizations and teams, from the order of every few minutes to the order of every few months. It depends. If there is something which is worth a new release or new update, they usually have schedules planned, and it can be from few minutes to few months. Any test failing or code not compiled will either block the code from being submitted to the code base, or else block the code from being released. So if the code is being submitted to the code base and it doesn't meet the criteria of the code, or has some failed tests in it, it won't be merged with the code base. And if it did, it won't go into release. All right. So guys, if you have any questions, please ask me. Right. Okay. Let's see some typical software development and deployment processes that we touched earlier very lightly. So to illustrate it, you have an engineer here makes a change to a local copy from the code base. He takes a copy from the code base and he tries to edit it. All right. The engineer send their change after that for the code review. So another engineer will go through the process of reviewing the software that was originally submitted by this engineer, right? So we have two cases now. If the reviewer doesn't approve, it will go again for the first engineer to be edited or to be re-implemented again or refactored again. If it's approved, you will be submitting your code to the code base, right? So you will have pre-submit checks that runs, and if they pass, the code will be submitted to the code base. So now you have two options as well. If the code doesn't meet the automation testing cases, it will go back. It will fail and go back to the first engineer again to be refactored or to be reconsidered. If it's okay, it will go into release, right? After before release, quality assurance run some tests and some criteria to make sure before we submit the code base into release, we need to make sure that they met the business criteria, they meet the technical criteria, and so on. If they meet all of these criteria, it will be distributed to the public. If not, it will be blocked. It should be fixed, or we should abandon it as an entire process. Does that sound clear? Type yes in the chat if you are following up. Do you guys have any questions? Are you good with the session so far? Okay. Thank you, Leila. Thank you, Sadiq. All right. So let's talk about the second thing that we are going to discuss. And I believe we will make it the last thing that we discuss because we run out of time. So the goals of quality, code quality. What are the goals that we want to achieve in order to get a high quality of a code? Okay, so let's consider this as a scenario. Okay, if you are buying a car, not hopefully not old as this one on the screen, but if you are buying a car, what do you want in the car? Usually, you want it to be safe, you want it to actually works, you want it to not break down in the near future, you want it to be resilient, you want it to be well architected or engineered, right? You want it to predict its behavior, or it should behaves predictably. Yani, when you hit the brakes, it should stop, right? Or slow down. When you again, if we ask someone what makes a car high quality, right? Some people say it should be well built, it should be well designed, it should be tested for safety and reliability before putting it into production, right? So making software is much the same. To create high quality software, we need to ensure that it's well built, well engineered, well designed before it goes into production. That what code quality is all about. The word code quality can sometimes be vague, and sometimes you will run into code quality concept from time to time. But code quality is a very much grounded in practical concerns. It can sometimes be concerned with small details and sometimes big details. So, for example, but the aim is the same. Whether it's a small detail or a big detail, the aim is the same: creating better software, creating better features, create a better design, right? Um, okay. Sometimes you look into the code and you say, okay, I just did a quick hack fix of some feature that it doesn't work for me, but this is a temporary solution for now. And some people will say this is excellent, well documented code. So we want to make sure that we know the difference between the two and how to get from, okay, this is a quick hack fix that solves the problem in the for now, and to transition from that into this is an excellent, well built, well designed piece of code. All right. So there are we talked a lot about code quality, but we didn't mention again the goals of code quality. What are the goals? I believe there is with this book they mentioned four high-level goals that we should aim to achieve when we write code. Right? What are these four? The code should work. It should keep working, not just work. It should keep working. It should be adaptable to changing requirements, and it should not reinvent the wheel again. All right. So again, I don't understand what does all of this means. Okay, let's discuss it one by one. It should work. How the code should work. This is very obvious. Yani, if you write code, it should work, right? Yani, we are trying to solve a problem, such as maybe implementing a feature, fixing a bug, or performing a task. So the primary aim of our code is that it should work. It should solve problems that we intend to solve. This implies that the code must be bug-free, right? So we need to well design the code in order for it to work. And yani, by meaning work, that the code is working, that means that we captured all the requirements needed for this piece of code. For example, if the problem was solving some sensitive operations to performance, like CPU usage or something like that. So to ensuring our code is performant comes it should meet the requirements that it should have this specific amount of CPU usage, for example. All right. And you take into considerations other factors as well, such as privacy, security, and such, right? So what do you mean by it should keep working? Okay, يعني it might work today, the code, but we don't know for sure if it's going to work tomorrow or in a year's time, right? Because يعني okay, let me ask, someone might ask a question and says, if nothing changes, then why would it stop working, right? If I didn't change anything about my business or about this feature, why should I change it? Or what should I consider make it changeable? The point is, nothing is static. There is always a changes. Always the changes in requirements, always the changes with features, right? So the code, of course, heavily depends on other code that will get modified, updated, and changed. Even if you don't change this feature, you might change another feature that depends on the original feature. So you have to take that into consideration. Any new functionality required may mean that the modification are required to do in the code as well. So even if you don't refactor old piece of code that depends on the feature, you might implement a new new features that require some modification to the old code, right? The problem we are trying to solve might evolve over time. Yani maybe if we have in the future some business needs in the future, or technology considerations, maybe a better technology came out or a better framework to implement them. So you have to take these considerations into mind, right? It should be adaptable to changing requirements, because again, businesses always change requirements through time. Nothing remains the same. Always there is a change. Okay, so let me describe that يعني, in two scenarios, right? These are two extreme scenarios in two different directions, right? Okay, so scenario A, let's think ahead. Let's actually think ahead and think of what could change ahead of time, all right? So, all right, so we are trying to predict exactly how the requirements might evolve in the future and engineer our code to support all of these potential changes, right? We will likely spend days or weeks mapping all of these ideas and thoughts, and think of how the code might evolve in the future, right? So if the code will normally take 3 months to complete, it might take a year or more to complete, all right? So what is the disadvantage in that approach? Yani, you will probably waste a lot of time, and a competitor maybe in the market will implement this feature ahead of you. So we will have a head start over you, right? By several months, not just days or weeks, because this feature should only be implemented and can be implemented in only 3 months. It took 1 year to think, brainstorm, think of how you structure the code to the things that might evolve in the future. And probably these predictions will change and might be proven wrong anyway, because no one can predict the future requirements that easily, or that with a very high percentage of يعني, excellence, right? So that's one scenario. This is a very extreme scenario. I'm just giving you the two sides of the coin, right? So the scenario B, let's do what we need to do for now. Let's not waste time on thinking how the code will be implemented or how the code will change in a year's time from now. Let's actually take these 3 months and do what the business actually needs for now, all right? So, يعني, you might write pieces of code within 3 months, but after that, after you actually release this feature and you wait for feedback from from the first set of users, it might be clear to that you are necessary have to rethink your code again or modify your code again. All right, and if you didn't make your code adaptable to changing requirements, you might have to do refactoring for the whole code and spend another 3 months again. All right, because you didn't actually put into consideration that the code might change in the future, or you didn't follow the best practices of making your code adaptable to change in the future, right? Just take in mind, these are two opposite extreme scenarios. We need to find this middle sweet spot between them. we need to think of how the code could be changed in the future, but without spending too much in it, and try to make our code as optimized as possible for now, with the ability and the flexibility that we can refactor the code again and do minimal work with it in order to adapt with these changing requirements. All right. So the last point, which is it should not reinvent the wheel again. What do we mean by that? Okay, let's see these pictures as an example. Okay, I want to write a software, okay, that load an image file, like the image you see here. This is the original image, and turn it into a grayscale image, right? So it's kind of a black white and white image. So I want an application to take a normal picture and apply a filter for it to be grayscaled or black and white. Okay, so we take this problem and divide it into sub problems, so it's easier to break down, right? So the usual step is, okay, we need to load some bytes of data from a file, picture, and parse the bytes of the data into an image format, and then transform the image into grayscale, and then convert the image back into bytes, and save those bytes back into the file. So these are the most basic steps that we have to implement, right? So again, what do you mean by it should not reinvent the wheel? Usually, well-established programming languages or development frameworks already have these basic features. They already have a way to parse bytes of data into an image format. It should be a function or something like that. So you don't have to implement it by yourself from the ground up. Yeah, right? So, يعني it okay, sorry. So why again? What are the reasons why it's best to make use of existing solutions over reinventing it? If you have a problem, there is probably a solution for it already. Most of the nowadays, if you are implementing some of it in this session, no, but we can do that in the future. That's why I need your feedback. If you guys want actual content that or a boot camp, as a very intensive boot camp that have a certification at the end, we can provide that as well. So please give us feedback like these if you want certifications or you want specific content that we can display. Please tell us in the feedback. All right. After the session, there should be a link sent to you by email for by now to take your feedback. So please write all of the feedback you want, or the ideas, or the suggestions, or the recommendation in the feedback form. Okay. I hope I answered your questions. So again, what are the reasons of using existing solutions over reinventing the wheel? It saves a lot of time. If we made use of the built-in support for loading files, it probably will take fewer lines of code and fewer minutes, all right? In contrast, if we are doing it again from the ground up, it will take a lot of unnecessary time and effort, right? It decreases the chances of bugs. If there is an existing solution, it is probably people have tested it people have experimented with it, and they give their feedback to the original engineers to provide some better use of it, right? So it is usually يعني have a very low chance of having bugs. In contrast, if you are doing it from the ground up by your own, maybe you don't have a field of expertise in that kind of solution, right? It utilizes existing expertise, as we said. If you don't have to learn something to build something from the ground up, which is already been built. You just have to use it straight away. And for example, why do you use Gmail instead of implementing your own email system? Because it is well built, well engineered, well secured, has features for privacy already implemented. So it's easier for me to just grab and go and use it, right? Instead of just trying to learn how to make an email system secure, how to make it scalable, etc., etc. It makes the code easier to understand because usually the engineers who developed this piece of code or this piece of solution, they are usually well documented and and they are usually more popular than your own solution that you are going to build. So if someone is going to see your solution, they will pick up what you are trying to implement very easy, in contrast of developing your own piece of code. All right. So I think we took a lot of time, a lot of your time for today. I know we started a little bit late, so we are going to continue next time. Let me just edit something. If you guys still have any questions, engineering student who is really bad at coding. Okay, what is your advice for a second-year software engineering student who is really bad at coding? Okay, I'm gonna finish the session and answer your questions in the most detailed answer that you want, right? So I finished editing. Okay, so we discussed today how code becomes a software and the goals of code quality. Did you guys benefit from this session or not? And if you did, what did you like about it? And what did you want to improve in this session? Please write it in the chat here or in the feedback form in your email. If you didn't receive any email, please register on our website and it will be sent to you automatically. All right. So next time we hopefully will discuss the pillars of code quality. Does writing high quality code slow us down? And a summary that summarizes this chapter for you. Okay. So do you guys have any questions related to this session? Sadiq, Layla, Umar, I believe, left. Who's else in here? Nabil, Sami. All right. Okay, cool. So Layla, how are you doing? Would you like to answer Sadiq? Or should I answer him?